Hello and Assalamualaikum Dr. Fariza. I am Shaffiah binti Muhammad. In this video, I'll talk about the third data modeling that we have performed for our group project, which is Linear Support Vector Machine, also known as Linear SVM. So, Linear SVM is a supervised machine learning algorithm that could be used to classify data into different classes. This can be achieved by making use of the hyperplane, or called as decision boundary, to separate the classes obtained in the dataset. So to obtain a hyperplane, an optimum hyperplane, it needs to have a maximum distance from each support vectors. The distance between a hyperplane and support vectors is known as margin. If in a case that we cannot draw hyperplane to separate two classes, then we will use a nonlinear SVM. We can then use kernel trick, or also called kernel function, to transform the nonlinear dimensional space to a higher dimensional space. In the initial parameter tuning, the cost is set to a default of 1 to study the influence of varying the cost to the number of support vectors for linear SVM. The model was continuously built with a different cost of 10 and 100. By doing so, we can come to an inference: when cost is being increased, the number of support vectors decreases because the margin becomes narrower. And we moved on to focus on training control, as we have performed parameter tuning in our previous assignment, and we decided that the best model is K-fold cross-validation. We apply the same technique here in the train function, together with a pre-processed parameter of center and scale to help us to center and scale the data. By doing so, we have a table to make comparison where we can see between accuracy, number of support vectors, and kappa value. We have the highest value of accuracy at 48.11% by doing K-fold cross-validation, and the kappa value falls between 0 to 0.2. And this indicates that it can only reach slight agreement with the review rating in the dataset. Moving on, we use confusion matrix to predict model accuracy using the different cost value mentioned earlier with the K-fold cross-validation. So our model best accuracy for test dataset was at 44.8%, while 47.8% of accuracy for the training dataset. As a final step, we evaluate C values to see which C values could give us the best accuracy. And we found that the best accuracy for SVM was when C equals to 5, with a value of 48.79%, and the kappa value is 0.1581. Even though we are not able to derive precision, recall, and F1 score through linear SVM machine algorithm, we are able to refine accuracy upon hyperparameter tuning. Unfortunately, this is not sufficient to justify an imbalanced dataset. Therefore, linear SVM is not suitable for this dataset to be used as a prediction model. Thank you.